talk is about to begin. Please take your seats and enjoy.
Mutable becomes immutable. The codebase is changed. Force push. I feel it in the compiler. Side effects bad. I feel it in the stack trace. Gibberish, elvish. I smell it in the logs. Much that once was written is now deprecated, for none still work who remember it. It began with the forging of the great collection functions. Transformations were given to the back-end devs, wisest and most patient of all. Filter functions were given to the front-end devs, great stylers and shapers of the user's view. And finally, aggregation functions were gifted to the engineering managers, who above all else desire power. For within these functions was bound the logic and flow to manage all state. But they were all of them deceived, for another function was made. In the land of merge conflicts, in the fires of Mount Deallocation, the Dark Lord Foron forged in secret a master function to control all others, and into this function he poured mutation, nullability, and his will to make all programming imperative. One function to rule them all. But the power of the function could not be contained. In his arrogance, Lord Foron committed it. It was pushed, merged without review, and in that moment was lost. Lost in the vast depths of commits for thousands of years. Until by chance, it came to a junior developer. Though he did not understand its power or evil, he pulled it nonetheless. He utilized the function. Through his code, the dark influence of the function began to spread, and now Lord Foron seeks it once again. The fate of all codebases rests in the most unassuming of hands, for the time has come where junior developers will shape the fortunes of all.
You're late.
Principal engineer is never late, nor is he early. He arrived precisely 5 minutes after the start of the conference talk.
Haha, Bendal.
Ah, Cotto, my old friend. And who are these interesting people here?
These are my developer friends.
Ah, well, let me introduce myself. I, of course, am Bendalf, the Dark Blue, at your service. I am a principal mobile engineer for a company called Vey. These are the things I love and I'm good at, and here's my socials.
Well, come on in, Bendal.
Ah, yes, very good. Now, it's important to mention that everything you see in today's adventure has been meticulously gathered into a Linktree link that you can see here. Every link, article, video, further learning that I refer to can be found here, including the slides themselves and all the code.
It is good to see you, old friend. But what brings you to our quaint neck of the woods?
Well, Cotto, I'm afraid a dark, looming, imperative evil seems to be growing across the land. Imperative evil or imperative programming is when you tell the computer how to do something, step by step. Here's some evil code right now. For example, this is me taking a list and summing up all the items in it. It's evil. It uses mutable vars, state mutation from within deep nested loops. Ugh! Declarative programming is the answer, where we tell the computer what we want to achieve and not how to do it. And functional programming is a subset of that, where we tell the computer what we want to achieve through functions. Here's some functional programming right now. In fact, it does the same as the code above. It sums up all the items, but it is short, concise, says what it does on the tin, and there's no external state mutation. Now, Koto, I need you to think very hard. Has any strange, dark events happened recently in the area that might move the plot forward?
Well, whilst I was coding, I found something.
Yes, go on.
I think it's a function.
Show me.
This is it, here.
Koto, seems very familiar. I have an idea. Throw it into the fire. Now, put your hand out, Koto. It's quite cool. Do you see anything, Koto? Any symbols, any letters?
Well, nothing.
Okay, good.
Wait.
Wait. That's Lord Foron's one function to rule them all, the evil imperative for each function. It would bring demise to all of Center Earth. We must destroy it.
No, we can't. It's been so incredibly useful.
Don't worry, Koto. Throughout our adventure together to mount deallocation, we will learn about many different collection functions, starting from very, very basic easy ones through to the more meaty advanced ones, so that you can replace your gross usage of the for each function with something that actually makes sense, and destroy it and save all of Center Earth. Consequences. Now, what is a collection function? Thank you for asking. Of course, in Kotlin, we have collections, your lists, your maps, your sets, etc. And collection functions are just functions on these collections provided by Kotlin's standard library. List.do something, map.do something. You get the idea. But the way I like to think about it is collection functions let you describe what you want to do with a collection instead of how to loop through it. Ooh, functional, declarative. Oh, yes. Now, I'm going to teach you a lot about many different collection functions, but it's going to be fast, and it's going to be high level. So what I want to do is point you to the other wizard, the most knowledgeable and wisest in my order. Of course, I'm talking about Lord Eignerman, the Dark Red. He, of course, is a master, not only in Kotlin and compose multi-platform, whatever that is, but also collection functions. In fact, every year he does the Advent of Code challenges, showcasing the very best of collection functions in like real-world scenarios. Check that out. Finally, Koto, we can't do this alone. We need a fellowship. In fact, we need this fellowship. This variable, the fellowship, you'll see throughout the entire code examples. It's simply a list of characters, some fake data. Not characters like strings, but characters like our heroes. Arrayagorn, Gitli, Lambdalas. No? Okay, fine. They are our heroes. They have names, fields, values. They're holding different types of items, weapons, blah, 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 blah. It does not matter what that data is, just that it exists. And you can, of course, check it out in the repository. Let's do this. We begin by passing through the mines of mutation. There is no chance I'm wearing this for a whole 45 minutes. Thank you. You'll be surprised to know that's the first time I've been applauded for ever taking anything off. Here we go. We must begin with the mines of mutation, some of the basic foundations, the easy ones to start us off with. To begin, we have the count function. Nice and simple. Count tallies up every single time an element in our collection matches a predicate. So it just adds up by 1 each time. You're going to see this visualization. I want to show you visually how these collection functions sort of work. In the center will be our black box, our collection function. On the left will be possible inputs and an example input. That's always just a list of shapes in this case. And on the right will be possible outputs and the output from our example. Nice and easy. So count. Count takes an optional predicate, and a predicate is just a fancy way of saying, take a single item from my collection and return either true or false on it. That's a predicate. So we're going to run count with the predicate that says, if the shape has 5 or less sides, return true. Otherwise, return false. Each shape will go in, and each time it returns true, the tally count goes up by 1, not by the number of sides of the shape. Good. Easy. Let's have a quick code example with the fellowship. I want to find out how many of my members are holding an item of food for some weird example reasons. So this is the code using the count function with this predicate. It obviously refers to the current character being iterated over, and are they equipped with food? Well, in our example, only Pip-Ping is holding an apple. So in our case, it's just a tally count of 1. Next, we have sum of, which again deals with numbers, but differently. This time, it sums up, it adds up values produced by each element in the collection. Each each element in the collection says what it wants to produce. So in the case of sum of, it uses what's called a selector function. And this is just an overly complicated way of basically saying, hey, what field do I care about in this class? Resolve it for each element and tell me what the answer is. So the sum of function here, we're going to use the selector, the number of sides, how many sides each shape has. As it goes in, the field is evaluated, returning an int, which is given to sum of, which adds it to the running total. Very, very boring. Here's a quick code example where I'm adding up all of the fellowship's ages for some weird reason. Next, we move on to a set of three: any, all, and none. Each of these take a collection and return a Boolean value, true or false. Any says, does any single one element in the collection match this predicate? If one does, then true. All says every single element must match this condition. If so, return true. And none, of course, is the opposite. Not a single element may match this condition, and if so, true. Now, all of them have different defaults. I'll let you explore that on your own, but we'll look at any as our example. We're going to use the predicate, does any shape have less than 5 sides? Obviously, we know that is to be true. But here's how it would work. The default is false, and we begin iterating. The star goes in with 10 sides, our default output does not change, and we continue. The square goes in, and our output now becomes true, and we can stop iterating. We can short circuit because, in the case of any single one did match the criteria, so we're done. Next, we have first and last. First and last are cool because they take a collection and return a single item from the collection. So if you've got a list of strings going in, you're getting a string out. If you've got a list of characters, you're getting a character out. But watch out. Both of these can throw an exception in the case that it cannot find a single element to satisfy its requirements. I'll tell you what I mean in just a second. Both first and last can take an optional predicate. So in the case here, we're saying, hey, find the first shape that has less than 5 sides. And it's not like any or the bool ones. It's actually going to give me the shape back. So the elements go in, and as soon as that predicate is met, the item that met the predicate is returned. We get the green square out. And it's the same with last, just it kind of needs to go through the whole rigmarole to find the actual last element that met its condition. So in both of those examples, we use the predicate. But you can, of course, use first and last with just the brackets afterwards, and you'll get either the 0 index item or the last item in the collection. Now, I mentioned that both of those can throw an exception in the case that it can't find a single item that matches the predicate or an empty list. So in this case, we can use first and last or null. So instead of throwing an exception, it will just give you null. I couldn't find anything. Go away. Next, we have filter, which is our first intermediate operator, which just means collection in, collection out. So we can continue to chain other collection functions on the end of it. Filter is very simple. Take your collection, filter out items we don't want, and filter in items we do want, keep the items we want. It uses a predicate to make this, in or out decision. So in our example, we're saying filter for red. So keep red. Every time an element goes in, it'll either result in a true or a false because of the predicate. And if it results in true, it's moved to the outputted list. List of shapes in, list of shapes out, just lesser in size. Here's an example. I need to get the hobbits together. We need to have a little 11sies. I'm hungry. So what I want to do is use the filter function on my fellowship and filter for hobbits. So I'm going to ask each character what their race is. If it's hobbit and it returns true, they're moved to the outputted list, and if not, they are forgotten about and not included in the delicious breakfast lunch thing. 9 characters in, 4 hobbits out. Next, we have take and drop. This is a bit of a strange one. Again, intermediate, collection in, collection out. But it uses numbers to sort of slice the list and just give you a chunk of the list back. Let me show you what I mean. With take and the number 3, it's going to keep and move to the outputted list the first 3 elements, forgetting everything else. The red square, gonzo. But with drop, it's the inverse. So drop says, hey, drop kick out of existence the first 3. Wow, this is tighter than I remember. Drop kick out of existence the first 3 and keep everything else. So with take, we knew how many items we were going to get in the outputted list. But with drop, we don't know. We're just throwing a certain amount away. And finally, in the minds of mutation, we have map. Now, map obviously takes a collection of a certain type in and returns you a list of a different type out. It maps each element to something else. It transforms each element using a transformation function. Again, fancy way of saying one type in, different type out. So we're not worrying about the logic here, but my list of shapes is going to be converted to a list of strings. Somehow I'm converting each shape to a string. We're getting 4 shapes in, 4 strings out, and the output is a list of strings. Here's a quick example. I'm trying to do a roll call of the fellowship. Hey, who turned up to actually help center Earth in this dire time? So I'm going to take the map function and this transformation, taking each character and returning this string. Obviously, the word return is omitted because it's the last line in there, but that's how Kotlin knows that we're getting a list of strings out. And it's just output like, hey, I'm Kotdo, I'm a hobbit, I'm here to help. I'm Sam, I'm a hobbit, blah, 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 blah. Good, let's do this. Come along now, Kotdo. We have moved through the mines of mutation and we've learned all about the basics. And the exit is over there. Let us take it and be rid of this place.
Okay, good idea.
Now, we must do so quietly as to not bring any unwanted attention to our presence.
I'll just quickly run the unit tests.
You'll do what? You fool of a junior dev! Force push the code next time and rid us of your stupidity. I think we got away with it. Boom. Oh no.
What was that?
That, dear boy, was a dark and ancient evil that lingers over every single codebase. It's a flaky unit test.
What should we do?
Kotto, you and the others head for the exit. I'll deal with this. You, demon! You shall not! Run! Well, that was easy. Come on down, Kotto. We need to cross the vast plains of reflection and learn about some of the more intermediate operators. First, we begin with distinct. Very simple. Distinct removes duplicates. It keeps a single of each item that is unique, keeping the first occurrence it finds. Let me show you the visuals. In this example, we have blue star, red pentagon twice. When we run distinct on this list of shapes, it'll find blue star and red pentagon, but then the second version, the second occurrence, it will omit because it's just looking for unique items. Easy. Now, I'm trying to figure out which races of Center Earth turned up to help the cause as well. So I'm going to use distinct here to help me. I'm first going to map my fellowship, my list of characters. I'm going to map it into a list of races. So that intermediate value will be something like hobbit, 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 dwarf, wizard, blah, 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 right? Then I'm going to run distinct on that. And what I get is the 5 races that turned up to help Center Earth. Great. Now, we need a way to organize our collections, to sort them perhaps in ascending order. And we can use the sort by wonderful collection function here. Sort by uses a selector. Remember, just a fancy way of saying, pick a property, I'll evaluate it. But the difference with this is the selector must result in something called a comparable, which is like an int, a double, a string, something that Kotlin knows inherently how to organize. Ints can be organized, right? So with sort by, and in this example, we're going to use the number of sides of the shape. Each element will go in. The number of its sides will be evaluated. An int will be returned. Kotlin takes all of those numbers and goes, okay, smallest to biggest, bang, there it is, ordered list. But some of you may have noticed there's 2 squares in there. Both have the same side count. How does that work? In that case, the original order takes priority. So green square came before red square. If it's the same, same in the outputted list. Okay. Here's an example. I want to sort my fellowship by age, youngest to oldest. So here's the code, and here is my selector. Each character's age is evaluated. That's a number. It's a comparable. Kotlin takes in all of those juicy numbers and says, well, Pip Ping, he's a young boy, and Bendalf, he's an old-ass man. Grumpy, old, close to death. So sorted by was great. That was ascending order, smallest to largest. There, of course, is sorted by descending, which, if you hadn't already guessed, is the other way around, biggest to smallest. And then there's sorted with. Now, sorted by is great, but sorted with, that's the creme de la creme. Sorted with gives you full control, customizability, and reusability for your sorting logic. With sorted by, we said to Kotlin, hey, that property, you do the sorting. With sorted with, we say, hey, Kotlin, hold my beer. I'm going to tell you how to do the sorting using what's called a comparator function. Now, comparator functions may seem weird. They look like this, but they're very simple. Let's break it down. It takes in two elements from your collection. They may be next to each other, they may not be. And one element might be revisited multiple times. But the comparator always returns an int. That's a number, something that can easily be sorted. And of course, that int can be anything. Now, I don't want to scare you, this is just an example comparator. In this very specific case, I'm taking the strings above and sorting them by shortest string to biggest string. That's all of that, like single line of math, dictates ascending order and all of the ordering. So that int can be anything, but it really just falls into three buckets. If the int results in something that's less than 0, it tells Kotlin some information. It says input x should actually come before input y. If it's 0, it means the numbers are the same, doesn't matter. And if the number is greater than 0, it tells Kotlin that input y should come before input x. Now, with all of those numbers and all of those who comes first rules, Kotlin's able to organize the list. And here's that exact same example with our fellowship. So ordering by names, shortest to longest. There's the comparator, there's our two characters, and there's the all-important return line. One character's name length minus another. With just that information, Kotlin's able to create this output. You can see it's like a tree. Sam at the top and a raygun at the bottom. Next we have flatten. We're going fast, so keep up. We've got flatten, which takes a collection of collections, a list of lists, and knocks out one level of nesting. So the list of lists has become just a list. I'm going to show you the visual. It's far easier to understand. Here I have a list of shapes. And when I run flatten on it, each sublist goes in and is broken apart. And its contents are actually given to a single layered outputted list. So list of shapes becomes list of shapes. Nice. Now here's a scary looking example, but let's again break this down. I'm kind of making a point that it looks a bit scary, you'll see why. So here, the first problem I've got is in my example code, I don't have a list of lists to flatten, so I need to make one. So I'm going to take my fellowship and map the list of characters into a list of items. My objective here, by the way, is just to find out, hey, everyone, what items have we all got together? Let's pull them out on the floor and see what we're working with, right? So we got this intermediate value. Then I can run flatten on it, and I get my single layered list of items. And that's fine. That works. But this was such a common occurrence, map then flatten. The geniuses, they made something else, flat map, which does it all in one line. Everything you saw in those two lines is the exact same output with just that one line. Nice. Now, partition is the next thing. We need a way to split our list into two separate teams based on some sort of logic. So we have partition. Partition uses a predicate, again, true or false, binary, to split into two lists. But the way I want you to remember it is, partition is filter on steroids, right? Filter, but you're keeping also the bits you threw away in a separate list. So when we run partition, any item that results in true, in this case, goes to the first list. Any item that resolves in false goes to the second list. So it looks like this. With our list of shapes in, we get a pair of list of shapes out, where the first list were the ones that passed the test, and the second list were the failures. Here's an example of partition. Now, the function is starting to corrupt some of the other team members, so I need to segregate the team. Oh dear. There's a bad road to go down, but here we go. So I'm going to use the partition function, checking each character's corruption level. How corruptible are they? Now, if they're very corruptible and it's true, I'm going to put them in one list. Kotdo and Boulamir, you can go and hang out in the corner over there. Leave the rest of them to be sane. Now, partition's great for creating two buckets, but what if we need more buckets? We have group by. Yay! Group by takes a collection and creates multiple buckets, multiple groups, based on the key you decide. I'll show you what I mean in a second. Now, group by takes what's called a key selector. It's just a selector, but whatever it results in is going to be the key, or the thing that's going to do the organizing. So in this case, we're grouping by color. Each item goes into group by, its color is resolved, and let's just imagine color is an enum, red, green, blue, whatever. And what we get out is a map where each entry has the key of the key selector that we evaluated, so color, and the value is a list of items that had that key. So blue has one shape, green has one shape, and of course red has two shapes. Nice and easy, map with that. Now, here's a quick example again. In case of combat, I want to find out what different weapon types, fighting styles we've got. Ranged, melee, magic. So I'm going to use this code. First, I'm going to filter the collection. I'm going to get rid of anybody not holding a sword. Sorry, Mergy, not today, sausage. And then we're going to use the group by function on the resulting characters that are all holding weapons. And we're going to just use this key selector. This may look complicated, but it's just asking, hey, what item are you holding? It's a weapon, what type? Ranged, melee, magic. And with that simple code, I get this output on the left. I get a map where each entry's key is the weapon type, and where each entry's value is the characters that are holding that weapon type. I think that's cool. Come along now, Cotto.
Bendalf, what was that noise?
That, dear boy, was a dark agent of Lord Thoron himself hunting us across the plains. One that even my magic cannot hold back. Run, Cotto, run! Fly, you fools! What am I doing?
Oh no, we're trapped.
Stay behind me, Cotto.
Give me the junior developer.
You will never have him! I'm sorry, Cotto. This is the end of the line, friend. It has been an honor serving with you.
Get out of here, you two. I can handle this.
Kotlin, it's Kaewin! Run, boy, run!
No developer can kill me.
I am no developer. I am a linter. Okay. I guess you're welcome, Kaewin. Good luck, you two. Assholes.
Now, Cotto, we come across the boggy dead modules where all tech debt goes to die. Cotto, you look bloody awful. The corruption is taking hold, my friend. Hold on just a little longer, we're almost there. We begin with the zip function. What a transition. The zip function is very cool because it takes two collections and smashes them together. So in this example, we've got two lists of shapes, and I want you to imagine the zip function like you do on your coat. You've got the little teeth, and when you zip it up, the teeth find their partner in the same sort of position, and that's zip. Jesus, oh my God. Anyway, when we run the zip function, it has an optional transformation. We're forgetting about that now. We're keeping it simple. I'm going to zip list A with list B, and here's what happens. At each index, the 0, the 1, the 2, items are paired up. And from our multiple list of shapes in, we get a list of pair, shape, shape out, where each item's partner is together with them. Very cool. One thing to note, that green triangle has been omitted because he didn't have a partner to pair up with. Oh. No? I'm fine. So here's a zip example. Watch out, everyone. There's orcs and goblins on the hill. We need to fight them. Yeah. I'm going to zip up my fellowship with the list of enemies. So one member of the fellowship is fighting one orc and goblin. It makes sense. Don't worry about it. Don't think about it too hard. So here's how I would do it in the code, and here's the output. I get a list of pair of character, where Cotto is fighting an orc grunt. Sam is fighting an orc archer. But something interesting is going on here. My enemies list is only 6 long, but my fellowship is 9. That means there's 3 members of the fellowship that are sitting on their butts doing absolutely nothing to help. Next, associate by. Associate by is weird. Takes a collection and turns it into a map. And you're probably thinking, hey, Bendalf, didn't we have that already with the group by? Well, yes, asterisk, you'll see why. Associate by takes each element and connects it to some value you decide. It associates one item with one piece of information using a key selector. So if I do associate by the color, you can see each item gets asked what color it is, and in the outputted map, the key is the color, and there's a single item, not a list of items, a single item that is associated with that color. But something interesting is going on here. I stopped at the red pentagon. I'm going to run it, keep running it again now, and see what happens with the red square. Red square overwrites red pentagon because in the map, the key of red was already used, so it replaces it. So that's interesting to keep in mind. So I need a representative from each race to come and huddle with me after the fight. We're going to talk, and then they'll go back and talk to their respective teams. I was really running on fumes at this point. So I'm going to use the associate by function, asking each character, what race are you? And as the characters go in, they will add themselves to the map, saying, I'm a hobbit, and I'm Cotto. I'm a hobbit, and I'm Sam. I'm going to replace Cotto. And what we get is this output of the number of races, so 5 races, with 1 representative from each. And Pip-Ping was our last hobbit in the fellowship order, so he is the representative that made it because everybody else replaced each other as they went over. Now, the opposite of that is associate with. And really, really simple. Now you know associate by. Associate with is this. whoop. Oh, shouldn't do that. I don't know, anyway. Basically, where the key and the value, you're going to switch them over. So you're associating each item with some value now. So let's see how that looks. Blue star goes in, and now the star, the element, is the key, and the item, the color, is the value. So that's really interesting to know that you can just flip around that sort of relationship. And again, in our code example, I just flew straight past that. Obviously, the hobbits, they wouldn't all get replaced now because the keys are the actual elements, the characters. Next, if you hadn't guessed it already, we've got windowed. Windowed is very cool because it takes our collection and creates little sublists based on a sliding panel. Let me show you how that looks. Windowed takes 3 parameters: a size, and a step count, and partial windows true or false. Let me show you the visual of how this looks. When I run windowed with these parameters, I get this little box. This is my window. It's size of 2. It can see 2 elements. It's going to take a snapshot, and that snapshot will go into my list of shapes that's being created. Now, step 1, it means it will move just 1 square, and it will take another snapshot. Step of 1, move 1 element and take another snapshot. And that's how windowed works. One thing to note here is that the green square and the red pentagon, they're in multiple sublists. Now, I want to create a night schedule, a night shift. We need to make camp and sleep and rest after the combat, but people need to take turns watching over us. So I'm going to use the windowed function with the size of 2, making sure that everybody always has a partner to watch over the night with. And when I run this on my fellowship, I get this output, a list of characters. This is my night schedule. The first shift is taken by Kadel and Sam, and the second shift is taken by Sam and Mergy. And then it's Mergy and Ping. Well, hang on a second. That's not very fair. Kadel at the start of the list and Boulamir at the end of the list, they're only on the night schedule once, whereas everybody else has 2 shifts. That's not fair. Here comes Chunked to the rescue. Chunked is very similar, but it creates consecutive, non-overlapping chunks. Let me show you what that means. With Chunked, you just do 1 parameter, the size of the window. And here's the sneaky bit, everyone. When you command click on Chunked, it's actually calling windowed under the hood. Exciting. So there is no chunked. It just passes the same value for size and step that you gave to chunk. So 2, so size will be 2, step will be 2. And again, let's see the visual of how this works. Window of 2, snapshot. Step of 2, non-overlapping, snapshot. What? Hang on a second. How did that pink circle get in a list on its own? Well, that's because partial windowed with chunked is turned on by default, which means Kotlin's like, I don't care if I don't get a full window of 2, 1 will do, whatever, I'm done, see you later. So that's chunked. Moving on, we have reduce. Reduce, we're almost there, folks, bear with me just a little longer. Reduce is weird. It takes your collection and boils it down to a single element, like first and last, asterisk. It reduces it if you're a kitchen nut. No? Anyone? My God, I'm sorry. I'll quit after this, I promise. Anyway, reduce takes what's called an accumulator function. Accumulators are so weird, we're going to take a quick sidestep to learn all about them. Here's the signature for accumulators, and here's some examples to glance over in a second. But let me explain. The first input in an accumulator function is called the accumulator. It's our sort of inbuilt memory, somewhere that we can morph and manipulate and change and save and pass on to the next iteration of this loop. When it's finished looping, the current state of the accumulator is the output. It's just like, that's the output done. T, obviously, in this case, is just the item being iterated over at the moment. And hopefully it makes sense that the return type and the accumulator are the same because one becomes the other eventually. Now, here's some example code. Please don't look into this too hard. I just want to show one really important thing. Here, I'm doing a really overcomplicated sum of string length thing, basically, right? But what's important is this return line. I'm taking the accumulator value, which is an int, adding in the current word's length, and returning it all in one line. That's the return line. So what happens there is it gets fed to the next accumulator for the next iteration. We'll have whatever that output was just then. That's cool. So back to reduce. Reduce takes an accumulator. But what's important about reduce is that its input type and output type are the same. So list of shapes in, you're getting a shape out. No questions about it. With reduce, we take the first item in our collection and make it the current accumulator. And then here it doesn't matter about the logic, but I'm basically trying to find the shape with the most sides. There's better ways of doing this. But in the logic, Each iteration will say, hey, accumulator, how many sides you got? And if it beats it, it replaces it until we finish looping and the current accumulator becomes the output. Here's a bit of code for you. I'm trying to find out the strongest character in my fellowship. So here's my code, again, filtering out useless characters and then reducing. Current champion is my accumulator. It's of type character. And challenger is of type character. This code here basically just compares the two, whose weapon is stronger, basically. And whoever wins that fight is returned and becomes the accumulator for the next run, and so on until we finish looping and it turns out Aragorn is the strongest, whatever. Now, a lot of people get reduce and fold mixed up, so let's clear that up. Because fold basically does the same thing. Takes a collection, boils it down to a single value, but there's some important differences. Firstly, fold's input type can be different from the output type. So list of shapes in this case, int out. Ooh. And also with fold, we are required to tell it the initial accumulator value. So here I've said, yep, 0, right? And that's how Kotlin knows it's going to be an int. Then again, it doesn't matter about the logic here, but I'm basically doing an overly complicated sum of the number of sides. Each shape goes in, adds itself to the accumulator, and so on and so forth until we finish looping and the accumulator becomes the output. So far, so good. Now let's have a little table just to really drill that in, right? They differ in 3 ways, reduce and fold. First, reduce's initial value is the first item in the collection, meaning that it's technically not safe. In the case of an empty list, there'd be an exception. And the result type for reduce is the same for the input and the output. List of shapes in, shape out. Whereas with fold, you are required to give an initial accumulator value, which means it kind of is safe. In the case of an empty list, it always has that initial value to fall back on. And of course, the input type can be different from the output type. So here's a fold example for you. Somebody got hurt during the combat, maybe, I don't know. And we're trying to figure out how much healing we can do as a team. So I'm going to use the fold function, setting our initial healing amount at 0. Then the total value here is the current accumulator. It's an int. And of course, the member is the current character being iterated over. Don't worry too much about this code. This is just like, hey, you, character, what healing items have you got? Add up the value of them and add them to the running total. Add them to the accumulator. And, obviously importantly, return, which makes it the accumulator for the next run. And same again, accumulator for the next run until we find out we have 50 healing, whatever the hell that means. Finally, last one. Running reduce and running fold. They seem really scary at first, but now you know fold and reduce, so simple. Let me show you. Just for transparency, I'm using running fold in this visual example. The only difference between running versions and non-running versions are the non-running versions always return just one item, the final accumulator value, whatever the accumulator was in the last step. But with running fold and running reduce, it returns every single accumulator value in the form of a list of all the accumulator values. It's like a ledger. I want you to think of it like that. Cool. We've made it, folks, fellowship to Mount Deallocation, where the evil for each function was forged all those years ago. Kotto, over there into the lavas, throw it into the fires from whence it came. Kotto, what are you waiting for? Throw it in.
Why? Why should I? After all, I found it. It's mine. My own. My precious.
Kotto, what are you saying? Friend, please throw it in. We've traveled too far. Destroy it. Be rid of it. End it now.
No. I'm going to keep it. I'm going to write loops through everything in the entire world.
No, Kotto, you mustn't use the for each function like that. You would bring doom to all of Center Earth.
Infinite loops inside of loops inside of nested loops.
Kotto, please, you would bring an imperative doom upon us all.
Imperative programming for all.
I am so sorry, Kotto. No matter who you are, I cannot allow you to use it like this. Please forgive me, friend. Abracadabra! It's me on an eagle. Acting. Well, folks, we've made it back to Revert Dell. I couldn't not, come on. And we've saved all of Center Earth. And along the way, we've learnt of imperative evils and collection functions to replace it. But I ask you, at what cost? Thank you all for coming to my ridiculous ass talk. Now, anyway, okay. Stop! Okay. It's important to know the links to everything I covered and much, much more. Obviously, I had 45 minutes just to cram in as much as I can, so check out the links for more learning to really dig into the nitty-gritty. Thanks, Seb. Again, mad props to AI for all the slop it helped me create, and of course, my best friend who helped me create the slop. There's my socials in case you want to pester me or check out my YouTube channel. Oh, he's got a YouTube channel. Oh. And of course, I am one of those assholes that has my very own branded merch. So I've got my dumbass face on stickers. I've got Kendroid pins that I model and print myself. And of course, each year's talk character sticker. So Refi, K7, and of course, this year's Kotdo, Kegel, and Column. Thank you all so much for your time. Have a great rest of Kotlin Conf. Let's get drunk!